Okay, this is going to be part 3 and a continuation of the diesel particulate filter, or DPF. Okay, so in 2004 they required a 90%, and that's why you're seeing that 0.1. That's basically, anyway, 90% reduction in 2004. In 2007 they said good job, now get that down to 99%, and we've stuck with that. That's why something with after 07 DPF and with SCR, like this engine, even though it's still producing carbon monoxide, but shouldn't run it indoors, but without an exhaust removal system. But if it is running, you don't have like your eyes burning, you don't smell the fuel. With this ISX 15, you can't hardly tell it's running from a smelling it or eye burning concept. So anyway, that's some of the good things about all this after treatment stuff. Okay, so we got two kinds of regenerations. We've got a passive regen, and it occurs a lot of times just under normal operation on over-the-road trucks, especially. So if you're loaded heavy, you're pulling hills, highway speed, trying to keep all that weight rolling, our exhaust temperature can get, and the ECM will actually track it and say, hey, this looks like we could have conditions to do a passive regen. So we're going to start restricting exhaust a little, lowering boost pressure, building heat in the exhaust, see if we can keep this truck rolling where we don't have any problems. But let's get the exhaust temperature up above 482 degrees Fahrenheit, and the O2 will start combining, and the exhaust will start combining with the soot and basically burning it up in the DPF. So about 85% of the time on a Class 8 over-the-road or highway truck, a passive regen happens and takes care of this stuff, so we don't have to have any kind of active. So when it's all working right, we shouldn't have to do any active regens, which we'll get to here in a minute. It should just all be passive. But the problem with that is we have to stay faster than 30 miles per hour. So if we drop down below 30 miles per hour for more than a few seconds, the ECM will abort the passive regen because it knows you may be coming to a stop. And it takes 20 to 30 minutes for a full regen to happen on a passive. So that's why it happens really well with a highway truck, but when you get to like a trash truck, a in-town delivery truck, a truck that's just running around Oklahoma City, it's not going to stay above 30 miles per hour generally for more than 30 minutes. So that makes the passive regen not happen like it's supposed to, and we'll get to the active regen here in a minute. One of the ways the computer helps with this passive regen is with a VGT. It can do what I said, start lowering boost pressure, creating exhaust back pressure, help create the heat, and give it a little extra fuel out the exhaust, either with that doser we talked about or with the injector. It's firing on the exhaust, but it can kind of have this passive regen happen without the driver noticing it. Now, I say the driver's not going to notice it. He may notice it's got a little less power when he goes to pull a hill because the boost pressure is lowered a little, but basically he can keep driving the truck and won't really notice it unless he's in a lot of hills. He may notice a little bit lowered boost pressure, a little less power, but it will still have the power to do the job. There's no lights comes on telling you you're doing it. It just kind of happens without you knowing it. I know, like driving a school bus that has all this on it, it'll do it and I won't know it until I come to a stop and I can kind of smell a charcoal grill almost type smell, and that's that DPF being hot, and you'll have a light come on, which I'll get to here in just a minute. Okay. Now if we don't have the VGT, we had the low pressure or series turbos, low pressure EGR system, then we might use that throttle plate to help regulate the air coming into the engine, kind of make it flow more exhaust and whatnot and heat it up. So anyway, two ways that can happen. So now let's get into the active. An active regen occurs when passive can't or don't work. So if you have problems where the passive can't do enough to get to it, which we'll get to later, or if the driving conditions, too much idling, too much stop and go, stop signs, stop lights, deliveries, all that keeps it from happening. We have to do an active. So we do this with OEM software or an electronic scan tool. So the driver may get a light that comes on that says DPF on the dash. The DPF light comes on when soot level reaches 80% capacity. So that's what turns that light on, and when it turns that light on, it sets a code. You can't do a active regen unless there's a code for soot level being over 80% or the DPF light comes on. We don't want drivers just thinking it makes their engine run better. Some of them thinks it clears the exhaust out, less back pressure, runs faster, so let's do a regen all the time and keep my truck running faster, and in their mind they think it has more power right after a regen. And it could have a little more, but we don't want them regenning all the time. We want it to only happen when it needs it. So if the driver has to initiate that, then, and trash truck drivers, some of these drivers in delivery situations, they know how to do this because they do it all the time. Your normal over-the-road driver, he's just going to take it to the shop and say lights came on. So it's kind of where your driver's trained. Some people have to do the stationary all the time, so there will be like usually a dash activated switch, or it may be out under the hood. Our school buses are out under the hood. It's going to have that code on I talked about. It has to see 0 miles per hour. Some of them make you turn the cruise control off even though it sees 0 miles per hour on the ECM. The transmission has to be in neutral, and the brakes have to be applied before it will let you flip the switch and toggle it. Once you toggle that switch, the vehicle can't be driven. You're sitting there for a minimum of probably 30-45 minutes or so, and the ECM will kick in and start heating up the exhaust, get it up almost 500 degrees, that 482 we talked about, and the stationary or active regen will start happening. So that's another word for it, is a stationary regen, active, same thing. So remember that during an active, temperatures can rise above 750 degrees. You'll have a HEST light come on the dash, which means it comes on when exhaust temperature is greater than 750 degrees and vehicle speed is less than 5 miles an hour. So a lot of times when it's doing that passive regen, when you come down to below 5 miles an hour or come to a stop at a stoplight or something, that HEST light will come on telling you your exhaust temperature is above 750 degrees. The reason it does that is it tells the driver that the exhaust is hot for a couple of reasons. Everybody says, well, just so nobody touches it. Well, nobody's going to go around touching exhaust anyway. That's a stupid thing to say. I've heard our administrators say that before when a driver asks what the HEST light means. Anyway, don't get me on soapbox. So what that means is don't drive it into tall grass around vegetation that could ignite from the exhaust. We had a problem back in the 70s when catalytic converters come out on gasoline engines, farmers driving their new pickup out into dead tall grass and the exhaust basically catching the grass on fire. That's a bad deal. So anyway, this could do the same thing. So it warns the driver that the exhaust temperature is really hot. The other thing it does, and nobody knows this but mechanics, but if it's 750 degrees, that turbo is extremely hot, so let the thing idle and cool down until the HEST light goes out before you shut the engine off. I know we're not supposed to let it idle, but it's very bad for that turbo to shut it off with that kind of heat. It bakes the oil that's inside it, and that's not good for it. So that's another reason for the HEST light. Anything above 750 degrees and less than 5 miles an hour, that HEST light will be on. Okay. Remember, during an active regen, temperatures rise above 1,000. I've seen them up over 1,100 degrees doing a forced regen. So last thing we're going to talk about here is, well, two more things, but there's no magic number that tells it when it's got too much soot in its DPF. Different driving conditions figure into it, all these things. So the computer has an algorithm that it measures, right, our inlet pressure and our outlet pressure, and it gets a pressure differential So we've got a delta P, a delta 2, or they're both delta P's, but 1 and 2. So inlet and outlet, and it's looking for a pressure differential across here. There's no magic number that sets that off. It's got an algorithm as to how much fuel, the operating conditions of the engine's been run under and all that. So there is a chance that this thing could slowly get plugged up if driving conditions were right and you had a few mechanical problems or something, to where this thing needs to regen, but it never turns that 80% light on because it slowly came up. I know that's a little bit confusing, but different things can cause that. So normal operating, it doesn't. So the computer kind of gets tricked in its algorithm, and this thing can get plugged up, have a lot of engine performance problems and all that, but it never turned a light on and set a code. So you can go in with the scan tool and look at pressures and see that, no, that's probably a little high, because you just kind of learn that stuff as a mechanic. So we can do a forced regen without a code if we have a scan tool like our laptop at the Insight, or a scan tool like the one we have from Bosch. There's different manufacturers. Snap-on makes one. Anyway, you can take that electronic tool and force it to do a active stationary regen at any time without any codes. So one thing you'll do if you ever have this DPF cleaned to reset that algorithm and everything, you will do a active or stationary regen once you pull this off to have it cleaned. That resets the computer so that it knows that it has a very clean one and resets its little algorithm and starts over. So you always have to do that, and there's no code for it, so that's why you have to have the scan tool to do that. Okay. So if you're having too many regens, which is a common cause, somebody will come in, problem, and say, this thing is regenning all the time. That's telling you there's a problem. We had a school bus here that constantly regened, and I was hearing on the radio all the time about it's losing power, all these lights are on, oh, it's doing a regen, it's okay. Well, it was doing it every trip. That shouldn't happen. Our buses don't run in an environment where they should regen all the time. So it also had a roll of black coal out of it when it took off, and I kept telling them it had an injector problem, and they never did fix it. They just kept on, and it's like leaking injectors cause you to regen all the time. That adds extra fuel to this, extra hydrocarbon for it to get rid of. So if you're regenning excessively, before you do anything to this, look your fuel system over and make sure that you don't have leaking injectors. So a leaking injector dribbles. So it's supposed to inject and be done. If it dribbles out, it leaks a little bit, then you're adding fuel that's not supposed to be there, and this thing catches it. Then you have to regen more often. This thing doesn't like oil. Oil's got more BTUs, so if your engine's pumping too much oil, you're going to do a lot more regens, and it'll melt this thing, actually. Too many regens, when you take this apart, there's, in the chapter, it shows you a bunch of pictures of it, but there is melted substrate inside here. And that's usually caused by too many regens, heating up too many times, too many BTUs being burned up in here, so extra raw fuel that's not supposed to be there. Oil especially, because it has more BTUs than diesel fuel. This thing doesn't like that. It doesn't like antifreeze being pumped through it. It'll ruin this if you get antifreeze being run through the engine, like an EGR cooler failure or a head gasket. Okay. Last thing, if it's regenning too much, look really close for leaks around this band or leaks somewhere in the exhaust, but especially where this thing is put together. If it's leaking on this side, you're letting some pressure out that the computer doesn't know about. It starts seeing too much pressure across here with those leaks. It'll regen too often. A lot of times you'll find a little crack in the flange where this is put together underneath the clamp. So that's another thing that can cause excessive regens. So remember, we've got 3 temperature sensors: temp in, temperature 2, which is right at the inlet. This is just basically the exhaust temperature. This is at the inlet of the DPF. This is exhaust temperature at the outlet. If any of those sensors are malfunctioning and reading weird, it will not do a regen. It'll turn engine warning lights on, telling you something's wrong. So you got to look with the scan tool and see, without the engine running, do all 3 of these read the same temperature? If you're looking for the one that's bad, If one reads 60 degrees cooler than the other two, or really any cooler, and the engine's completely cooled down and the exhaust is completely cool like this one is right now, that would tell you that that one has a problem because it's reading different than the other two.